Hello and warm welcome to this webinar organized by Veryx. Deploying SDN with confidence. Thank you for taking the time to attend this webinar. I'm Deepak Raghunathan. I'm your moderator for today's session. To give you an overview of this webinar, software-defined networking, or SDN, is emerging as the new paradigm that makes the network programmable, making it possible for organizations to create agile, responsive, and manageable network infrastructure. SDN holds promise of being cost-effective, adaptable, and efficient, making it ideal for bandwidth-intense and dynamic nature of today's applications. SDN technology is changing the way the networks are being designed, built, and operated. SDN enables elastic networks such that the network control is decoupled from the forwarding functionality. Even though there are lots of benefits in adopting SDN, there are often some roadblocks in the path to SDN. The IT team may not possess enough knowledge about SDN and how to deploy SDN. Often, the belief could be that existing network with traditional hardware meets the current need. Currently, there aren't industry standard methodologies or tools to compare the SDN performance with that of the existing network. In this webinar, Veryx will present the challenges that could be faced during SDN adoption, the key design factors that need to be considered in SDN adoption strategy, key benchmarking parameters that should be used to gauge the SDN network, and test tools and methodologies to compare SDN solutions. This webinar will have 2 poll questions during the course of the session and finally a Q&A session. I would allow you 30 seconds to respond to each of the poll questions. And please feel free to type in your questions during the course of the webinar, and we'll respond to those queries during the Q&A session at the end. Let me now introduce the 2 presenters for today. Anton Basil, Vice President, Engineering at Veryx.
Hello everyone, I'm glad to be here for this webinar.
And Bhuvaneshwaran, Technical Architect, Veryx Technologies.
Hi everyone, this is Bhuvan.
Thank you, Anton and Bhuvan. Before we go further, let me briefly introduce Veryx to you. Veryx is a provider of communications, test, and measurement solutions. Over the last 12 years, Veryx has provided automated test solutions for various segments, and the recent ones include carrier Ethernet, data center, cloud, and SDN. Many of Veryx customers also utilize our consulting and professional services for testing network equipment and for deployment of their networks. For more information, please visit our website or contact us. I would now have Anton take over and get started with his presentation. Thank you.
Thank you, Deepak. We will first go over some of the potential challenges faced during the transition to SDN architecture, and then cover aspects of design and benchmarking performance. So in terms of challenges faced, the first question that needs to be handled is, compared to existing traditional network, will this new architecture be stable and reliable? As a network architect, I might be pretty confident about the current network stability and reliability. So when transitioning to SDN-based architecture for supporting upcoming application, the question is, will this transition impact the network performance and meet application demands? Secondly, will there be interoperability issues with the existing network? What the potential issue that would be faced when deploying the SDN network? Will this new architecture interoperate with my existing network? Will these 2 networks remain as 2 independent islands and be managed separately? Thirdly, how to measure performance of this network Will this new architecture be able to meet the performance demand of the current network as well as upcoming applications, which require high bandwidth and be dynamic and elastic? Next, will the new architecture meet the scalability requirements? Can this new architecture scale to meet the current demands as well as future demands for scalability? We need to know the scalable limits and have a mechanism to measure those scalable limits so that we can confidently transition to the new architecture. Next, how to troubleshoot and monitor the SDN network. With the current network, I may have the ways and means to monitor as well as troubleshoot my network. How can I do it when I transition to new architecture? Will my existing tool be able to monitor my new network, or do we need to go for new tools? Even if there are, will they provide the same level of monitoring and troubleshooting capability as the existing ones do? Finally, we need to know how to benchmark SDN components. Now the focus shifts to the individual component that form the SDN network. The component includes controller, switches, applications, and orchestration software. What test tools and methodologies do we need to use to benchmark these components? We need to compare and contrast various components available in the market. For example, how do we compare the available controllers? Based on which criteria should the inferences be made? Similarly, switches, applications, and orchestration software need to be compared, and best of these components need to be identified. We have presented the challenges in deploying the SDN architecture, and before we move forward to address these challenges, we would like to take some feedback from the audience. Deepak, over to you.
Well, thank you, Basil. We'll now have our first poll question for today's session. In your screen, in a few seconds, you will see our first poll question. What is the primary challenge that your organization faces in adopting SDN? You have 4 options, and please feel free to select your option, and you have 30 seconds and your time starts now. The options are lack of benchmarking tools and methodologies, lack of performance data for comparing SDN components, lack of SDN related skills, and interoperability between SDN components and legacy networks. Please click on one of the displayed options. Anton, while the audience poll is in progress, what do you think is the primary challenge that most organizations face?
I look forward to hearing from the audience out there, but I feel there could be varying responses based on how far the company has come in assessing and implementing SDN-based networks. But my sense is that once we have hard numbers in terms of SDN network performance, there would be more enthusiasm to shift towards the SDN paradigm.
Thank you, Anton, for the response, and thank you, audience, for also selecting the poll option. I think we are in a tie between the last 2 options, lack of SDN related skills and interoperability between SDN components and legacy networks. I now request Anton to continue with his presentation.
Thank you, Deepak. Now I will cover the key design considerations while designing network based on SDN architecture. First, we need a clear understanding of what kind of network services will be offered using this network. Once there is clear understanding of that, we can optimize the network for the network services to be offered. By optimization, I mean the kind of traffic pattern expected in this network, the traffic direction, and dynamic nature of traffic. With these factors in mind, we need to find out whether the network can meet the stated goals. Ideally, a network which is adaptable, manageable, agile, and responsive is what would be expected. Next, what kind of SDN network are we planning to deploy? Is it based on OpenFlow or non-OpenFlow based components? OpenFlow is a standard-based implementation, whereas the non-OpenFlow is based on proprietary protocols or combination of multiple standard protocols. Also, do we want the entire network deployed with single vendor devices or multiple vendor devices? Based on the answers, we can arrive at whether the network has to be OpenFlow or non-OpenFlow based. Network configuration and provisioning capability is another important factor that needs to be considered while designing the SDN based network. Typically, in a virtualized network, there would be more physical virtual devices and the network is more dynamic. Hence, configuration and provisioning becomes a complex and resource intensive task. When we design SDN architecture, it is also important to consider the size of the network as well as the number of entities that needs to be configured. This will help to decide on the orchestration software for managing virtual networks, since orchestration software should help in efficiently provision dynamic networks. Next, we should consider what performance we could expect from SDN based network. This is the key factor that needs to be considered before transitioning to any network deployment. Now the focus shifts to the performance metric and how they are measured. The measured metric should give the clear indication of how the network will perform its intended functions under normal, stress, and exceptional conditions. Network resiliency is another factor that should be considered before transitioning to any new network architecture. With 5 nines and 7 nines services offered by service providers, the resilient network becomes the need of the day. We need to know how the SDN architecture adapts to network element and link failures. Specifically, we need to know how quickly the network recovers from failure condition with the SDN architecture. With networks more prone to security threats, it becomes mandatory that the network is protected from those attacks. The network should possess the ability to identify the threats and provide a quick, effective, and dynamic response to such threats. Any network architect would consider network security as the first and foremost aspect of network deployment, since it has the direct bearing on business continuity. Moreover, the mechanism provided should be consistent and possess the ability to be enhanced based on potential future security threats. Finally, we need to consider the components of the network from design viewpoint. A network has to be stable, reliable, adaptable, and manageable in order to provide better service to the network consumers. Does this new architecture have all the attributes of dependable network? Do the components that form the network have those attributes? We need to keep in mind when we contemplate transitioning to new architecture. Having covered the design considerations, we will now present key benchmarking considerations for SDN. So, when we ponder which are the key factors to be considered while benchmarking a SDN deployment, the first area to consider is how to compare SDN controllers. The first and the foremost step is benchmarking the SDN controller, the brain of SDN network. The comparison can be done under the categories like programming, functionality, and performance aspects by asking relevant questions. Under programming aspect, the questions are: can it support proactive and reactive flow provisioning? Can it support overlay and underlay networks? Can it provision SDN as well as traditional network? Does the controller support open API or proprietary API? Then, under performance aspects, the questions could be: how much time does it take to provision the SDN network? What is the size of the network this controller can provision within acceptable delay? What kind of SDN network elements this controller can provision? How much time does this controller take to provision a flow onto a switch? What the flow provisioning rate of the controller? Does the controller support resiliency? Is the controller reliable? And finally, coming to functionality aspects, the questions are: how much of decision making is in the controller? How much of intelligence is in the switch? Do we need to deploy single controller or group of controllers? Does this controller have all the required applications, or do we need to enhance the controller with additional applications? Secondly, as part of the benchmarking process, we need to consider SDN network performance criteria. Usually, there would be a set of criteria based on which any network performance is measured. The same holds good even for network that is based on SDN architecture. The performance metric that can be measured for SDN deployments are network topology discovery. One of the key performance metric is the time it takes for the control and management entity to discover the topology of the network, and that could be for network initially as well as during topology changes. This performance metric can be compared with the network discovery time of the current deployment. Based on this metric, steps to further improve or fine-tune the network based on the SDN architecture could be taken. Next, path computing delay. The path across the network to reach from source to destination endpoint is the key for traffic flowing across the network. For any decision to transition to new network architecture, this performance metric needs to be considered. Hence, the time it takes to compute the path becomes the prime performance index. Keep in mind that the path computation delay measurement should be done on a network which is in stable state as well as in volatile state. This performance metric needs to be measured and analyzed for each of the network services being offered. Next, we need to consider the time to provision and reprovision a flow. From the management perspective, the flexibility of provisioning and time to provision are seen as the performance parameters. There are two types of provisioning: proactive and reactive provisioning. In addition, we need to consider time taken to reprovision as a performance measurement. Based on the network provisioning and with the measure of appropriate provisioning metric, the network behavior based on SDN architecture can be better understood. Ideally, we should see considerable improvements here too. Application traffic performance is another key performance metric that we need to consider for newer application, where application-based bandwidth provisioning and traffic prioritization is needed. Nowadays, upcoming applications expect the network to identify the application traffic flows and provide differential treatment based on application. This being the case, it mandates a methodology to measure the application traffic performance. Next, we look at the aspect of network services performance. With the network services being the key element of communication across IP-based network, performance of these network services become one of the prime factor in designing a network. The performances are measured in terms of availability and responsiveness in providing the service to the requesting entity. When transitioning to the SDN-based network, the ability of this network to provide all required network services, and that too in a timely manner, would be important to consider in the decision process. The availability of network services during the stable state and volatile state, as well as timeliness in providing such services, need to be measured. Finally, we come to security considerations. Any network should have a mechanism of evaluating the network security based on a well-defined process. This process will mandate a periodic evaluation of network for vulnerabilities, historic trend of attacks on remotely accessible service, predict potential threats, and ability to protect the network against such threats. From the performance aspect, the network security should be measured in terms of time to detect a threat, ability to mitigate and prevent it effectively, and protect the network from future threats. Hence, before transitioning to SDN-based network, security aspects of this new architecture need to be measured and analyzed. Another area to consider in benchmarking network is to understand how adaptive is the network to dynamic conditions. Adaptability is the measure of network ability to overcome dynamic changes and handle exceptional conditions while providing the same level of performance. Some of the factors that could influence the network performance are failure of network components and links. We need to understand whether network recovers and continues to provide service when any of the network components or link fails. Next, workload mobility. Whenever a workload moves from one host to another, does this network have ability to redirect the traffic onto new location of workload without any impact on the traffic? Thirdly, dynamic load balancing. We need to assess whether this network has ability to distribute traffic across multiple links as well as multiple servers offering the same service. Finally, scaling workload. We need to benchmark to understand whether this network has ability to handle sudden increase or decrease in workloads. If the answer is yes for all the above questions, then the network is adaptive. This can be verified before deploying by emulating such conditions and measure network ability to overcome such situations. Such measured values should give the required confidence when planning the transition to an SDN-based network. Finally, we also need to know how scalable is the network. Network scalability is the measure of network's ability to handle increased workload without any degradation in the network performance. The factors that could influence the network scalability are, firstly, path computing delay. How much of increase in path computation time when there is an increase in network workload? Will it impact dynamic flow provisioning? Secondly, topology discovery delay. Does topology discovery time exceed the acceptable limits when the network size increases? Thirdly, reconvergence time. With the increase in network workload, will there be any impact on reconvergence? Does it affect existing service. Fourthly, service provision time. When the network size increases, will it take more time to provision the service from management entity? And finally, flow setup delay. Does flow setup time exceed the acceptable limits when the network scales? If the answer to all the above questions is no, then the network is scalable. We can try to answer the above questions by emulating an SDN based network. We should see how the network scales based on the above factors and comparing with the acceptable limits. This will help in deciding the transition to SDN based network. Before we present an overview of test methodology and the test tool to verify, validate and measure SDN network capabilities, we will have the second audience poll. Deepak, over to you.
Thank you very much, Anton. Well, it's time for our second poll question now. And as you can see, the poll question is displayed on your screens. And the question is, which southbound interface is your organization using or considering for deploying SDN network? We have 4 options on your screens: OpenFlow, I2RS, NetConf, and OBSDB. You have 30 seconds to fill in your responses. And while we do that, I'd like to say that we have covered the overview of the design and benchmarking considerations, and clearly there are a lot of considerations to keep in mind. Well, we have the poll responses, and it looks like there's an equal distribution between OpenFlow, I2RS, and NetConf. Now, the natural question that could be in everyone's mind is, how do we make these measurements? And for that, we have Bhuvan, who's going to take you through just that.
Well, thank you, Deepak. Now, I'll briefly go over the test methodologies and tools for SDN. I'll start with SDN test methodologies. In general, SDN technology has a broad scope, and though there has been a lot of hype about the technology, currently there aren't a lot of standards out in the industry to benchmark the implementations. There are a few standard groups working towards the development and standardization of SDN. One among the group is Open Networking Foundation, who is leading the industry's effort to promote SDN adoption. As part of their standardization effort, ONF has defined a protocol called OpenFlow for controller switch communication. Now, I'll be discussing here the available test specifications and methodologies for benchmarking SDN controllers and switches that implement OpenFlow protocol. Firstly, for verifying the compliance of OpenFlow switch implementation, ONF has defined the conformance test specification. This is available at their website. Secondly, for benchmarking OpenFlow SDN controllers, Veryx has defined the test methodologies for measuring OpenFlow controller performance. By the way, this test methodology has been published in IETF as an introductory draft. This draft defines a number of tests that may be used to measure the performance, scalability, and reliability aspects of an OpenFlow SDN controller. The tests could also be easily extended to non-OpenFlow controllers as well. Here, I would like to mention some of the metrics that have been suggested in the IETF draft. Firstly, in terms of controller performance characteristics, we need to measure the rate at which the flows have been set up and the time it takes to set up a flow, as well as the time it takes to provision flows end-to-end. Secondly, for assessing the scalability factor of the controller, we need to determine the maximum number of concurrent OpenFlow connections that a controller can support at a time and the optimal number of switches that it can handle without impacting the performance, as well as the number of flow entries that the controller can accommodate in its flow table. Thirdly, for assessing the reliability factor of the controller, some of the metrics suggested are to determine the controller's behavior under exception and error conditions, also to find out the controller's ability to overcome denial of service attacks, as well as in teaming mode in the event of failure, need to determine the time taken to switch from one controller to another controller. And finally, we need to find the time a controller takes to recompute a path in the event of network components failure. So these are all the factors that needs to be assessed to ensure the reliability of a controller. Overall, the motive for Veryx is to define the test methodology to provide a standard way of measurement so that vendors and users can evaluate their implementations. Based on the defined IETF draft, we have conducted some throughput tests in our lab for some of the OpenFlow controllers using Veryx Packet Blaster SDN tool. At this time, I'll be glad to present our test observations for various controllers in the public domain. Before discussing in detail about the test observations, I would like to mention the test objective and its configurations. The objective of this throughput test is to assess the controller's flow throughput behavior for varying number of flows. The test had been configured to use OpenFlow version 1.0 and TCP connection setup. The test was performed with a constant switch load of 100 switches and then stepped up to increase number of flows from each switch in every iteration, essentially ranging from 1000 to 1 million flows. The test was conducted on a number of controllers versions such as Beacon, Mastro and Floodlight running on a standard server platform. The server platform had dual Intel Xeon CPUs with 16 GB of RAM. Now I'll be discussing about our observations for this test. Here we have observed a higher flow throughput for the Beacon and Mastro controllers as compared to Floodlight. On the other hand, the throughput of Floodlight was consistent regardless of the variation of flows. But the throughput of Beacon and Mastro dropped considerably beyond certain number of flows. Also, we have conducted similar tests on other controllers. To know more about the results for other controllers, please contact Veryx. Moving on to next slide, here we present the latency test that we have conducted in our lab. The test was repeated with same set of configurations to assess the controller's latency behavior under varying number of flows. Here we have observed that Floodlight controller had the lowest flow latency as compared to Beacon and Mastro controllers. Finally, to conclude, based on the controller's performance, we feel that Beacon and Mastro controllers could be more suitable for networks managing large number of hosts and supporting applications which are not time sensitive. Secondly, Floodlight controller could be more suitable for smaller networks supporting time sensitive applications. Hope the information that we have provided here is useful to the audience. We are continuing our effort to perform these tests on upcoming versions of controllers in the public domain, and we will soon publish them on our website. Over to you, Deepak.
Thank you, Bhuvan. You have indeed given us a quick overview of methodologies and tools to benchmark SDN performance. I'm sure the audience, which represents a cross-section of equipment vendors, enterprises, and service providers, would have found the presentation helpful from the viewpoint of assessing and benchmarking SDN components and networks. We have a few questions from the audience already, and I would request those of you who have any more questions to please use the box on the top right side of your screen to type in your questions. Moving on to the Q&A session, the first question we have is, what are some typical issues you foresee when interoperating SDN network with traditional networks? Anton, can you take this question, please?
Yes, Deepak. Some of the typical issues that you may foresee would be the performance bottleneck at the network edges. Some could be the glitches while provisioning the end-to-end services. That could be other problems too. You might encounter the assurance of end-to-end QoS when you do it across SDN and traditional network. The other challenge I could see at this point in time is security. So clearly there are some issues that need to be addressed, but definitely it can be overcome. Over to you, Deepak.
Thank you, Anton. The second question for today is, there are many open source tools already available for benchmarking SDN controller performance. How would Veryx's tool compare with them? Bhuvan, can you take this question, please?
Yes, Deepak. This is a good question. Basically, open source tools that are available in the market support benchmarking only a few performance parameters, while Veryx tool covers much beyond that. To highlight further, Veryx tool is a software-based test tool that provides scalability in terms of emulating thousands of nodes and millions of flows. In addition, it supports benchmarking reliability aspects as well. Also, it provides flexibility to select a wide range of traffic types. Secondly, Veryx tool also provides a comprehensive reporting and performance comparison option to end users, and above all, this provides a programmable interface for test automation. Over to you, Deepak.
Thank you, Bhuvan. Would you point me to any industry standard based performance reports for SDN controllers? This is the third question for the evening.
Deepak, let me take this question.
Sure, Bhuvan. Okay.
Well, though there are no industry standard benchmarking specifications available currently, Veryx has suggested a number of tests to benchmark SDN controllers' performance as part of the published IETF draft. Based on these test methodologies, Veryx has conducted a considerable amount of benchmarking tests on various controllers. A performance report have been prepared based on this, and it is also available with us. Please contact us if you are interested in getting them. Over to you, Deepak.
Thank you, Bhuvan. And for the lack of time, the fourth and final question for today is it possible to measure the performance of non-open flow based SDN controllers? Are there any tools out there in the market? I guess Bhuvan would be answering this question too.
Yes, Deepak. Yeah, the answer for this question is yes, it is possible. There aren't any open source tools available to test non-open flow based controllers. There are non-open flow communication mechanisms available, and some of them are I2RS, netconf and OVSDB, each vendor in the segment adopting different communication mechanisms. However, Veryx is planning to support measurement for some of the widely used non-open flow based controllers. To know more about the support and the functionality of our tool, please contact Veryx. Over to you, Deepak.
Thank you, Bhuvan, again, and thank you again both Anton and Bhuvan for this presentation that you made today. The presentation highlighted many of the challenges faced during SDN transition and factors that are to be considered during network design. A proper design and good benchmarking methodology to verify, validate, and measure SDN network performance should give confidence to network architects to transition to SDN-based networks. With the evolution of test methodologies and many test tools, it should be possible to measure the new network before complete deployment. I would like that you all for taking time to join us today. I trust that the webinar would be beneficial to each one of you. I think with this we conclude our webinar session for today, and please feel free to get in touch with us for any further clarification or additional information. The contacts of the two presenters for today, Anton Basil and Bhuvaneshwaran, is published on the screen now for you. You may please make note of it and directly ask any questions to them. Our general contact information is also provided below. Please feel free to get in touch. Thank you, and wishing you all a great day and a wonderful weekend ahead.
Thank you.
Thank you.